My name is Grace Simonton,
And I'm Griffin Renaro.
and we're here with Reese Adams. So, Reese, could you start off by saying what your typical day at Hyper looks like?
Yeah, for sure. First off, thanks both for having me. So, being that this is my first semester as a graduate student, I feel like I kind of have a unique daily agenda. Basically, alongside a lot of the typical first semester like documentation, whether it's establishing or launching a graduate committee or whatever, that's kind of been a main push for the first semester, just so I can kind of get all that busy work out of the way and then move on straight into research. But as of late, a lot of what I do is getting familiar with craft, all of its systems, all of its subsystems, working alongside Matthew to ensure the commissioning of craft, as well as basically validating that we're getting good results. So usually, I've been coming in on a pretty routine basis almost every day to perform both room temperature and cryogenic fatigue and tensile tests of polymer matrix composite materials. So basically, I come in and get a test set up, perform the test. If it's room temperature, you can get probably a handful done a day. But if it's cryo, it usually requires, install and then cool down, pulling vacuum, et cetera, et cetera. So that's more of a longer process, but you'll catch me doing that quite often. I also bond some of the strain gauges to the samples themselves. So really the main push right now is just testing, but it's been a lot of fun and quite the learning experience. So.
Well, awesome. So, what's your favorite thing about working at Hyper then?
Probably, I've kind of always thought that Hyper was unique in that it's got quite a diverse workload. Other places, have you do one specific task. Hyper is it's a very independent learning process. Of course, you can rely on others to learn and ask questions, etc. But it's very, it's up to you to kind of choose your own destiny, right? So you get to do all the research, you get to do all the testing. So for me, I think it's just the diverse. You step 5 steps in any direction, and you stumble across a new experiment, and it's very related to industry. In that, I feel like industry kind of relies a lot on the engineers to do kind of everything, right? You oversee manufacturing, the development, drafting of plans, and so I think that Hyper does a very good job at preparing you for that, and preparing you too if you want to stay in academia for longer duration. So I think that's been my favorite thing. Is just it's something so novel, and something that there's high expectations, and as we'll probably get to later, developing my professionalism. So it's been fun.
Very nice. So you joined Hyper as an undergraduate. Since then, what's the most important thing that you've learned from Hyper?
Ooh, good question. Let me think. Well, I think so. I came in. I was a transfer student into Washington State University from my community college back in Spokane, Washington. And so coming in to Hyper was, I think it was my second semester as an undergrad here at WSU. And I came in not really knowing much about cryogenics at all. I was probably one of those people with you that would say, when somebody said, "What is cryogenics?" I was like, "Doesn't that involve freezing people?" That was my understanding at the time. So I think coming in and coming from a point of not understanding very much to a point of not complete comprehension, but when it comes to materials specifically, I think a pretty good comprehension of what's going on. And so I think that has been one of the most interesting things that I've kind of learned over the course of Hyper, is getting familiar with materials research and seeing craft up in commission now. It's just I still sit here today and just am kind of baffled of where I've been, where I've come, not knowing much to where I am, and I'm really appreciative of Hyper for that opportunity to grow that way.
Awesome. So, before you move on to a different project or a different area of study, what are you hoping to achieve here at Hyper?
Another good question. I think I'm not alone in that most people's objective of Hyper or coming to Hyper is to learn, right? Plain and simple. And I think that Hyper does a very good job at doing that. So really, I think that both learning as well as hopefully using that learning to then contribute to your field of study or field of interest. So, like I had said previously, coming from a place of very little understanding to now having a very good understanding, I now have the tools I need to go ahead and contribute back to what I'm so interested in, right? So this materials research of cryogenics. So I think that's kind of where I stand on that, basically.
So through that process of learning, so it is said within the lab, like fail stands for first attempt at learning. Have you encountered this at your time at Hyper?
Oh yeah, yep. I think that the ability to fail is, it's at Hyper, it's unique too, in that there's room for mistakes. I think that the amount of kind of fail safes we design in every single project and experiment allows for that as well. And there's been multiple times too, especially this semester, through really getting a crash course on craft of its systems and its subsystems. There's been a couple of times where I've done something maybe out of order. I've, just something that isn't necessarily, the way it's supposed to go with respect to install of specimens or pressurizing the test cell. And I definitely think that, there's not necessarily a negative connotation with failing, but it's something that sticks in your mind more when you do make a mistake. And so when you make a mistake, like I'm sure I have, and everybody here at Hyper has, you tend to remember it more. And I think there's a lot of room for wiggle with respect to making those mistakes and learning from them here. And so specifically for me, it's just been learning craft and utilizing craft as a testing tool and making little mistakes here and there that I've learned from and excelled thereon.
Awesome. So if you could speak to anyone from recorded history, who would it be and why?
I was kind of thinking about this one a little bit ahead of time. I haven't really been approached that question before. I think my answer would be a little cliche. So initially I go to somebody like Stephen Hawking, right? Just because it's like, that everybody knows that it's a household name, right? But I also think that, we have a lot of documented video of him. So if you really wanted to talk to him, you can kind of talk to him through watching videos of him lecture or whatever, So I kind of go back to maybe let's go to somebody a little bit more historic. So maybe somebody like Isaac Newton, arguably one of the most influential scientists ever. And it's two birds with one stone because I could talk to him about what his century was like, right? So that and learning some of what he has to share, academically.
Very nice. So you mentioned it before about your schedule going into the physical Hyper building, but due to the pandemic, how have you been handling lab work during this time?
Yeah. So I think a lot of people struggle with this mix of leisure space and workspace, right? Where we're kind of, a lot of us are forced to combine both recently. And so for me, I'm kind of thankful for one of my internships at Unitech Composites, because this last summer, I was allowed to work remotely from my apartment for 40 to 50 hours a week. And so you'd catch me with my little TV dinner tray and my little remote, my little laptop they gave me, just writing manufacturing plans. And so very early on, I kind of mastered the idea of turning that side of my brain off when it needed to be, but turning it back on when it needed to be, right? So I'd work my 40-hour day, turn it off, and then, be able to go back to my wife and, our dog and just kind of have leisure time too, but doing it all in the same space. So I'm thankful for having had that because I feel like I've got a good sense of, of that. As far as, staying involved with the lab recently though, because ideally it would be nice not to have to go in just to limit exposure. Teams as an interface has been very, very helpful. Everybody's staying involved, interactive. We have channels there just for random discussion even, so I think that just being involved and interacting through that has been a helpful medium for a lot of us. And so for me too, I try not to go into the lab, but when I do, I do. And when I don't, I can go on Teams, right? So
you talked a lot earlier about how Hyper is very much a learning lab. So how has it helped you learn how to become a professional?
Yeah. So I think, again, I'll probably just have to relate back to the diversity of experience that's offered here. I think that, there's been a lot of opportunities for me to be, improve my public speaking skills. I've never been one for public speaking. I'm sure a lot of people get a little nervous, at least when they have to present something. But there's been a lot of opportunity for me to do that and just provide discussion about theory and build, and just there's every day is a constant learning experience. So that in combination with this diverse knowledge base of people, of experiments, having that completely around you 24/7, I think has really prepared me for what industry, or if I want to continue in academia, has prepared me for both avenues, basically.
Very nice. So on a lighter note, what is one of your more funny slash interesting stories that you've had while being in the lab?
Yeah. So I'm trying to think. I think interesting. One of my first experiments that I was a part of coming to Hyper, this would have been, I think, a couple of years ago now, maybe a year and a half ago. I was in charge of performing Gelbo flex tests on thin polymer films. So basically, we had a dewar that we would put liquid nitrogen in, and then we had a Gelbo flex tester that would actuate linearly and torsionally. And so we'd put this film around it, and we'd perform these tests, and we'd see how many cycles to fracture, basically. Did not survive very long at cryogenic temperatures. Room temperature did survive, but I think it was interesting for me because that was a very preliminary stage of development, kind of just like what happens when we do this type of research. And for me, it was novel because I'd never done anything cryogenics before because it was one of my first experiments. So I think seeing that, and then now talking to people like Shell about doing these origami, bellows designs, like seeing it kind of come full circle and seeing what it takes to, what the effort that goes into something like that, and just kind of seeing it, like I said, come to fruition. It was really, really cool, especially because I'd like to research kind of the theory behind things. I enjoy the build side of things too, but I really like to expand on theory. And so that was, very theory heavy. And so kind of seeing that was really cool and interesting to me.
Awesome. So obviously Matthew is going to graduate this year. So how is the craft team going to change once he leaves?
Yeah, good question. So right now, Matthew's big push is to get the data he needs, as well as commission craft completely to finish off his thesis. And so for me right now, my main big push is to just help him along, learn, and prepare myself for the eventual research that I will be performing. So as it stands now, it'll probably be mostly independent research on my behalf. Down the road, if I ever need somebody else on my team to help, with testing or maybe even offering enhancements to craft as a system too, that's always an opportunity. For the time being, since it's very preliminary, basically what it will be is me just performing the research on craft that I need, as well as anybody else who needs research performed on craft. There's talks about possibly bringing in third parties to test some of their materials on craft, so I might be in charge of some of that. So really just pursuing my thesis, as well as performing tests for other people. And then if it maybe later in the future, some people will join craft, but for the time being, it'll just be me and my research. So.
Very nice. So final question, for anyone who is watching this video and may want to join craft or Hyper in the future, do you have any advice for them?
Yeah. So like I said previously, I came in as a transfer student. And so I had 2 years of just kind of generic engineering experience under my belt, seeing as I got an engineering degree as my AA. So, I even came in a little bit intimidated just because of all the people that you're surrounded by that are just, very intelligent people, and they've been doing what they've been doing for a long period of time. So coming in from knowing very little and then being surrounded by people, it can be intimidating to some people. And I could see that even being more so when, you're a freshman, right? If you're a freshman coming in, having little to no engineering experience and then being surrounded by that, I could see how that could be intimidating. But all I can say is that the people here want to see you succeed. They're here to help you learn. And I think that the fastest track to get out of that kind of intimidating period is just to ask questions, to be involved, to go to, all the grad students or postdocs or Jake and just say, why is it that we're doing what we're doing? What is the purpose of this experiment? Just simple questions like that. Like, nobody cares if you have no understanding of what's going on. It's okay to learn, So that way too, eventually with that understanding, you can excel, and, contribute to your grad team, or if you become a grad student and, beyond, you can contribute to the field of research that you want. So yeah, just ask questions and try not to be intimidated by the community.
Awesome. Well, I just want to say thank you. You've answered all our questions.
Really appreciate you taking the time out of your day to meet with us.
Thank you both for your time. I appreciate the opportunity to get my name out there in the lab a little bit more. So yeah, thank you.